Hi, this is Abdul Rehman Khan. My topic is NLTK and Spark near real-time text analytics. The problem that I'm trying to tackle is measuring the opinions of people on social media. What are they saying? Are they what are the sentiments? What are the emotions that they are expressing regarding a particular thing? Are they expressing some positive sentiment, some negative sentiment, or is it just a journal comment that they are making, which doesn't have any polarity associated with it? The question arises: why sentiment analysis? Sentiment analysis these days is becoming one of a very popular commercial applications as well. There are very popular commercial applications which big companies are using to measure the sentiment of people on social media. It can impact the business, measure the performance of their campaign, which directly means ROI, whether you need to stop the campaign or you need to expand the campaign. You can measure the quality of your product so that you can improve the quality. You can improve customer service. If for a specific region you see a lot of negative sentiment, you can improve your customer service in that region. Managing customer complaints. Again, in the similar way, if you are receiving a lot of complaints from one region and not from another region, you can manage your team accordingly to handle the situation. You can measure the performance of your competitors, whether they are performing good. Are the other people happy with their performance? Will it will your customers go towards go towards your competitor, or do they have some offer is which is like enticing your customers to churn away from you and join your competitors? You can also do some political sentiment analysis, that in which region, in which country, what are the political sentiments? Is it good that we have an alliance with China or not? So these kind of questions can be answered by the sentiment analysis. The technology stack that I'm using is Spark 2.2 and Python 2.7. For sentiment analysis, I'm using the NLTK toolkit, and this all is running on a virtual machine of CentOS. How I did the project was I divided it into three phases. In the first phase, I read data from Twitter and store it in a file. For the simulation purpose, I downloaded a already built-in file, already compiled file of tweets, about 1.5 million tweets, which I split and sent to a directory to simulate the streaming process, just like we did in the class. Then I read it from Spark streaming, and using the NLTK toolkit, which has a Vader lexicon based sentiment analyzer, I tag the tweets for their polarity, for positive, negative, and neutral. Then I do some aggregation on top of these polarities and count how many tweets for each polarity are there. Then using Matplotlib, I draw a bar graph to see how many positive, negative, and neutral tweets are there. This is just a snapshot of the code itself. I will go through the actual demo, so I'll cover this. This is the end visualization that I have. There are some challenges that we face while doing sentiment analysis. It's very hard to distinguish spammers, which are there just to add numbers and not show the real sentiment. They can be spamming all the posts, like they can be just copy pasting the same text again and again on different threads. Also, there is a problem in sentiment analysis to know about sarcasm. Also, with the emergence of GIFs and memes, it is hard to know the true sentiment just by text analytics. Lexicon-based sentiment analysis that I'm using actually doesn't cater for all languages, because you define different rules for that how you want to treat different words. If you want to have this kind of a sentence structure, so if you need to do it for another language, probably you cannot reuse this. There are certain catchphrases that in a certain political scenario might completely change the sentiment of the whole sentence. The future enhancements that I'm looking for in this current project is I want to shift it to AWS cloud and involve Kafka between Twitter and Spark. So I want to read the data from Twitter and write it onto a Kafka producer. And then from Spark side, I need to have a Kafka consumer that provides the data to Spark. Also want to use either Cassandra or MongoDB to store the polarity of individual tweets. Right now I'm on the file system. Because I'm using the file system, I'm not storing the individual tweets. I'm just aggregating the data based on their polarity. Also in the future, I want to store more additional data for the tweets, like Twitter handle, hashtags, the time of the tweet, etc. Then using the visualization, once we have the DB, so we can do other visualizations which can be time specific as well. Now I will quickly move on to the demo itself. Just to check that I have the correct version, I just started PySpark. It tells me that it is 2.2, so Spark is 2.2 and the Python version is 2.7.5. Also, I had to set up some parameters in the .bash profile. I had to set up Java home correctly and Spark home and add them to the path variables. Then I created a structure for my final project. I can show you the structure. You see there are some codes, some data, and I've created some input and output and staging folders. Similar to what we had done in lab, in the lectures, I will simulate the run for the files, and also in the meanwhile I'll start the Spark consumer as well. So first I'll start this. Just to show you what it is doing, I'll again look at the tree. See, one file has appeared in input and one in staging, and it has already split the files into this in this directory. So if I do, now input is growing. So if I start this Sparks, now I've started the Spark job. So what will happen is that it will start reading this data set which has Twitter data. So what I can do is I can quickly show you what data is inside this. So it has 4 columns, but I'm interested only in the last column. So just to show you what the Spark is doing is, if I run the tree again, it is creating some folders with the output part 0. So I'm writing the data into the file system, just to show you what is inside any of these files. Some of them can be empty, but at this point in time, since I am constantly providing the files at a faster rate, so it might not be empty. But in a real world scenario, Spark Streaming API can have empty files. So if you see, I have 2 columns where I have positive, negative, and neutral tweets, the count of those tweets. So this will keep on running. In the meanwhile, I can show you how I read the data from Twitter. So this is, I use the Python API. I can change this search string, that whatever it is. Right now previously I had taken big data analytics. Right now I have taken, just converted it to hashtag big data. So I'll restart and run it again. It will show me the tweets for big data. Just to show you that it is still working, it will take some time. I'll just run the tree command. You can see the output folders are increasing. So it will keep on working. I'll just quickly go through the visualization part. So what I'm doing is, I am taking all the files within this hierarchy using the os.walk command and concatenating all the files into one panda frame. I am checking that if the file has some size, so it's not an empty file. So then what I'm simply doing is, I'm just counting the sentiment and summing the number of tweets. So it will give me the total number of tweets. So I'll run it once, since the job is still running, the Spark Streaming is still running, the split and run is still running. So I'll run this, and the numbers are like 450,000 neutral, 170,000 positive, 48,000 negative. So just to show you that it's going to update, because on the back end it's still running, I'll just restart it again. So if you see, now the numbers have increased, and this is just presenting it as part of a bar plot. As I mentioned, this is the basic structure. I have some future enhancements in mind, which I'm planning to use, and I'm actually planning to implement this in my work as well, and extend it to other languages. But for the time being, due to the time limitations, this is what I have. Thank you very much for listening. Bye bye.